Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you and your family in the best of health. Dear students, this lecture is for grade 8, boys and girls both wings, subject chemistry, chapter number 3. And in this lecture, we will do the remaining topics and exercise of chapter number 3. This is my 21st lecture, and I am your lecturer, Mrs. Saira Jamal. The topic which we are going to discuss is about the electron affinity. What is electron affinity? Electron affinity is defined as the maximum amount of energy released when an electron adds up in the valence shell of an isolated atom to form a uni-negative gaseous ion. Electron affinity is the reverse of ionization energy. In ionization energy, it was the maximum amount of energy absorbed or required when an electron is removed from the valence shell of an isolated gaseous atom. While electron affinity is the maximum amount of energy released when an electron is added or arrested in the outermost shell of an isolated gaseous atom, and to form a uni-negative ion, definitely when an atom gain electron, it will get negative charge. So X is an element, and when it will gain one electron, it become a uni-negative ion. Uni means one, negative charge, and the energy will released, that energy which is released is called electron affinity. Electron affinity is an exothermic process because the reaction in which energy is released are called the exothermic reaction, and this process is exothermic because in this case also energy is released. Electron affinity values are represented with a negative sign because the exothermic reaction, the release of energy we represent by negative sign. Metals means group number 1A, 2A, they have low electron affinities, while non-metals have high electron affinities, like the those which are present at the right side of the periodic table. Unit of electron affinity is kilojoules per mole. Coming towards the variation of electron affinity in a period, as we move from left to right across a period, the electron affinity generally increases. Electron affinity, ionization energy, and electronegativity. These processes increases from left to right along the period and decreases from top to bottom along a group. Why electron affinity increases from left to right along a period? This is due to increase in nuclear charge. Increase in nuclear charge means charge on nucleus increases. The charge on nucleus is positive charge, and positive charge particles which are present in nucleus are proton. Neutrons has no charge. That's why the charge on nucleus is only due to the protons. So increase in nuclear charge means the number of protons in nucleus increases, because when we move from left to right, atomic number increases. So when atomic number increases, definitely the number of protons increases. As a result, nuclear charge increases. Not only the number of proton increases, but the number of electrons also increases. So those extra electrons, they are more tightly attracted towards the nucleus, because more proton will attract those extra added electron more tightly towards the nucleus. But shielding effect remain constant in each period, because all the elements which are present in same period, they have same number of shells. Therefore, alkali metals have lowest and halogens have the highest electron affinities in each period. Alkali metal have the lowest electron affinity, and the group number 7 halogens have high electron affinity. Why not the group number 8 element? Because the group, in case of group number 8 element, their outermost shell is already completely filled, so they don't need to gain electron. That's why their electron affinity value is 0. But when we move from left to right along the period, electron affinity increases. Halogens have the highest electron affinity value, and alkali metals have the lowest electron affinity value. As I told you, the reaction is exothermic, and exothermic reaction, the values are represented with negative sign. So you can see all the electron affinity values are represented here with negative sign. Dear student, there is some exception as well, like I told you that the electron affinity value increases from left to right, so minus 60, then 0 for beryllium, while beryllium has 0 electron affinity. Inshallah, you will learn these exception in grade second year, but just keep overhead, just keep this in your mind. When we move from left to right, electron affinity increases. You can see in this case, minus 60, then minus 122. I am leaving the exceptions. These exceptions I am leaving. So minus 60, then minus 122, then minus 141, and minus 328. That is the highest electron affinity value of the halogens. You can even see the second case, minus 53, then minus 134, then minus 200, minus 349. So you can see that electron affinity values increases from left to right along the period. I told you I left the exceptions. These exceptions you will learn inshallah in grade second year. Variation of electron affinity in a group. The electron affinity decreases from top to bottom in a group. Reason is that due to increase in shielding effect. Because when we move from top to bottom, due to increase in shielding effect, the added electron bind less tightly to the nucleus as the number of shell increases. So the outermost electrons are far further away from the nucleus, so they are less tightly bind by the nucleus. As a result, when the electron is added in the outermost shell, less energy is released. Example is group number 7A. As I told you that if we take the example of group number 7A, fluorine, chlorine, bromine, and iodine, and when we move from top to bottom, you can see electron affinity value decreases, minus 328 for fluorine, 349 for chlorine. Again, there is an exception. Inshallah, I will explain in first year. Minus 325, and the lowest is minus 295. So the lowest electron affinity value is for iodine. It means that when we move from top to bottom along the group, electron affinity value decreases from 300, it decreases to 295. Negative sign, I told you, for exothermic reaction, which show release in energy. Next topic is electronegativity. That is the next property. What is electronegativity? Electronegativity is the ability of an atom to attract the electron towards itself in a chemical bond. When two atoms combine together and they form a bond, so the electrons which are shared between them, they will be attracted by one atom more as compared to the second atom. So this type of pulling of electron by an atom towards itself after making a chemical bond is called electronegativity. So the element which will pull electron more toward itself will get a partial negative charge, and another element will get a partial positive charge. Partial means half positive charge and half negative charge, because it is not completely taking the electron. Only the shared pair electron they will pull more towards themselves. That's why we can say electronegativity is the ability of an atom to attract the electrons towards itself in a chemical bond. Bond will still there, and but only the pulling of electrons will be different. One atom will pull electron more toward itself and will get partial means half negative charge, and the second electron will be partial electron deficient and will have partial positive charge. We have a figure which will show a scale of electronegativity of the element, and it was devised by a scientist, Linus Pauling, who was an American chemist, and he devised a method for calculating electronegativities of elements. So that scale is called Pauling scale. According to the Pauling scale, maximum electronegativity value minimum value is of francium, which is an element of group number 1A, and the maximum electronegativity is of fluorine, which is present in group number 7A. So the minimum electronegativity, which is francium, that is 0.7, and the maximum is of fluorine, which is 3.98. We can take it as a 4. If we round it, so we can take it as a 4. So this is the maximum electron. If someone asks you what is the which element of the periodic table has maximum electronegativity, then the answer is fluorine. Fluorine of group number 7A has maximum electronegativity. And which element has minimum electronegativity? Francium of the groups 1A of the periodic table has the minimum electronegativity. The other elements, you can see that when we move from left to right, you can see 0.98, 1.57, then 2, 2.5, 3, 3.4, 3.9. So 2.984. It means that when we move from left to right along the period, electronegativity increases. And the maximum electronegativity value is of the group number 7A, that is the halogen family. If we compare group number 7 with other groups, so which group element have maximum electronegativity? Answer is group number 7A of the periodic table has maximum electronegativity. Variation of electronegativity in a group. Electronegativity decreases from top to bottom in a group. The reason is that this is because an increase in the atomic size decreases the tendency to other shared pair of electrons. That is, the nucleus, the outermost shell is farther away from the nucleus and it is difficult to pull the electron more towards itself. Along the group, that is group number 7 or also called group 17, fluorine, chlorine, bromine, iodine, when we move from top to bottom, you can see electronegativity values decreases from 4, 3, then 2.8 and 2.5. The minimum electronegativity is of iodine. It means that when we move from top to bottom along the group, electronegativity values decreases. Variation of electronegativity in a period, although I told you that electronegativity increases from left to right in a period. What is the reason? The reason is that the nuclear charge increases from left to right in a period. The nuclear charge increases from left to right while the electrons enter the same shell because the number of shells remain constant. The electron in the same shell cannot shield each other effectively from the attractive forces of the nucleus. Hence, the increased nuclear charge attract the shared pair of electrons in strongly. This results in higher electronegativity. Due to small size, the nucleus have greater pull on the outermost electron, and even the electron which are shared with other atom, it will pull the electron more towards itself. As a result, I told you that a partial negative charge or half negative charge will appear on that element. Electronegativity of period number 2 elements. Electronegativity of period number 2 elements. First one is lithium. Electronegativity of lithium is 1, beryllium 1.5, boron 2.2, 2, carbon 2.5, nitrogen 3, oxygen 3.5, and fluorine 4. So in the previous case, I told you 3.9, and when we rounded it up, it becomes 4. So you can see that this is along the period, although I mentioned it vertically, but this is period, okay, not group. So you can see that lithium, which is present in group number 1, its electronegativity value is 1, and fluorine is present in group number 7, its electronegativity value is 4. It means that electronegativity values increases from left to right along the period. Coming toward the review exercise, encircle the correct answer. MCQ number 1. Number of periods in the periodic table. How many periods are in the periodic table? 7. 7 periods are 1, 2, 3, 4, 5, 6, 7. 7 periods are present in the periodic table. 8, 8, 7, 16, or 5. So correct answer is 7. There are 7 periods in the periodic table. Which of the following group contain alkaline earth metals? I told you group number 2A of the periodic table are called alkaline earth metal. Group number 1A are called alkali metals, and group number 2A are called alkaline earth metal. Number 3, which of the following elements belong to group 8A? This is group 8A, helium, neon, argon, krypton, and xenon. So let us see: sodium, magnesium, bromine, xenon. Yeah, correct option is xenon is an element of group number 8A. Next MCQ is about main group elements are arranged in dash group. Main group elements mean I told you group A. Group A elements are called main group element, typical element, representative element, normal element. So there are 8 main group elements and 8 transition elements. So main group elements are arranged in how many groups? 8 groups. Period number of aluminium, atomic number is 13 and mass number is 27. The smaller value is atomic number because atomic number means only the number of protons. So keep this in your mind that the smallest number will be atomic number and the greater number will be mass number, because mass number is the sum of proton and neutron. So definitely the sum will be greater than only atomic number, like only number of protons. So while writing the electronic configuration, you have to follow the small number. Okay, you have to consider the small number, which are the number of protons. So 13 is the atomic number. We will write the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p1. Then the valence shell electronic configuration, or the outermost electronic configuration, is 3s2, 3p1. N value is 3, so period number is 3. And if you want to find out the group number, so 2 plus 1, 3 is the group number. But over here they ask about the period number. So N value is 3, so the period number of aluminum is 3. Valence shell electronic configuration of an element, M. M is an element and its atomic number is 14. And we have to find out the valence shell electronic configuration. So atomic number 14, first write the electronic configuration, then consider the outermost shell, which is 3s2, 3p2, and this 3s2, 3p2 is the outermost shell or valence shell electronic configuration. So correct option is B. Which of the following elements we expect to have greater shielding effect? Lithium, sodium, potassium, rubidium. Lithium, sodium, potassium, and rubidium, they belong to same group, that is group number 1A of the periodic table, which are also called alkali metal. You can see the shell. 2 shells are in lithium, 3 shells are in sodium, and 4 shells are in potassium, and 5 shells are in rubidium. And I told you, more shells, more inner electron, and more greater will be the shielding effect. So rubidium has more shell, it has more inner electron and greater shielding effect. Correct answer is rubidium. As you move from left to right across a period, which of the following do not increases? Electron affinity increases, ionization energy increases, nuclear charge increases, shielding effect remain constant. When we move from left to right along the period, shielding effect remain constant because the number of shell remains constant. All the elements of group 2A are less reactive than alkali metal. This is because these elements have. Why group 2A elements are less reactive than alkali metals, which are called group 1A element. Group 2A elements are less reactive than group 1A element. Why? Because group 2A elements have high ionization energy, they have relatively greater atomic size, similar electronic configuration, or decreased nuclear charge. So definitely when we move from left to right, the ionization energy increases. So group number 1A have less ionization energy, and group number 2A have a higher ionization energy. So the correct option is the group 2A elements are less reactive because they have high ionization energy than group 1A or alkali metals. Coming toward the short question answer, the first question is write the valence shell electronic configuration of an element which is present in third period and group number 3A. So period number 3, third period means that the N value is 3. So N value is 3, and group number 3A means that the number of electrons are present in the outermost shell are also 3. So we can write the valence electronic configuration like 3 because the N value is 3 or period number is 3, and the total number of electrons are 3. You know that the third shell has S, P, and D, but there are 3 electrons, and S can accommodate only 2 electrons. So we will put 2 electrons in S subshell, and 1 remaining electron we will put in the P subshell. So 3s2, 3p1 is the electronic configuration or valence shell electronic configuration of that element. Question number 2, write 2 ways in which isotopes of an element differ. What are isotopes? Isotopes are the atoms of an element which have same atomic number but different mass number. They are called isotopes. So different, same atomic number means they have same number of protons, but the number of neutrons are different. So the first difference is they have different mass number because mass number means sum of protons plus neutrons. So as the number of neutrons vary, definitely the mass number will also vary. They have different mass number, they have different physical properties. The physical properties of an element depends upon the number of neutrons. As number of neutrons or mass number is different, definitely these elements will have different physical properties. And you can also write they have different number of neutrons. You can also write that difference. Question number 3, which atom has higher shielding effect, lithium or sodium? You can see lithium and sodium both belong to same group number 1A of the periodic table, lithium and sodium. And we have to find out the shielding effect. Lithium has 2 shells and sodium has 3 shells. And again, as I told you that as the number of shell increases, then shielding effect also increases. So sodium has, you can see due to 3 shells, sodium has higher shielding effect. Reason, because of the greater number of electronic shell and number of electrons present in the inner shell as compared to lithium. In case of lithium, the inner electrons are 2, but in case of sodium, the inner electrons are 2 electrons in the first shell and 8 electrons in the second shell. Total 10 inner electrons are present in sodium. Only 2 electrons are present in lithium. So due to more inner electrons and more shell, sodium has a higher shielding effect than lithium. Question number 4, explain why sodium has high ionization energy than potassium. Why sodium has high ionization energy than potassium? Sodium and potassium belongs to same group, and ionization energy, as I told you that when you move from top to bottom along the group, ionization energy decreases. So sodium comes first, then potassium, because hydrogen, then lithium, then sodium, after sodium is potassium. So as sodium comes before, or it has high position in group than potassium. So sodium has higher ionization energy than potassium, because sodium and potassium belongs to same group, and the ionization energy value decreases from top to bottom. Number of shells increasing top to bottom within group, which result increase of inner shell. So potassium has greater shielding effect, results in weaker ionization energy. Greater the shielding effect, weaker will be the ionization energy. As potassium has more shell, that is 4 shells, and sodium has 3 shells. So sodium has lesser shielding effect or lower shielding effect, hence higher ionization energy. While potassium has greater shielding effect, results in weaker ionization energy. Question number 5, alkali metals belong to S block in the periodic table. Why? Why alkali metals or group 1 elements of the periodic table are called alkali metals? Group 1 elements of the periodic table are called alkali metals. They belong to S block because their valence shell electronic configuration completes at S subshell. So they have 1 electron in their outermost shell. As they have only 1 electron in the S subshell, so they are group 1A element, and they are called S block because their outermost subshell is S, or the electronic configuration completes or stop at S subshell. That's why they have they are called S block elements. So this was all about the remaining topics of chapter number 3, the exercise MCQs and short question answer of chapter number 3. The extended question answer, inshallah, we will discuss in our next lecture. So till next lecture, take care. Allah.